Okay, we've got two theorems to learn in this lesson, and they're both about triangles. Okay, this first one is called the triangle inequality theorem. Okay, first, let's make sure we know how a triangle is always labeled. Okay, we've got three sides to a triangle, so we use commonly just A, B, and C. Okay, A and B is not so important which is named A and B, but C is important. Okay, C is always the longest side. Okay, no matter what kind of triangle it is, acute, right, scalene, okay, it doesn't matter. C is always the longest, or at least one of the longest if the longest is, two of them or all three of them. Okay, so there's A and B are never bigger than C. Now, it also has a special name if it's a right triangle, okay, and that is hypotenuse. Okay, the hypotenuse is always C when you're talking about right triangles, which is the one across from the right angle. Okay, so the hypotenuse is C. Okay, because C is always the longest side. Alright. Now, this is the triangle inequality theorem. It says that A plus B is greater than C. Okay, it has to be. Okay, if A plus B is not greater than C, then you don't have a triangle. Okay, I'm going to show you in a second here. Okay, but as long as A plus B is larger than C, then you can make some kind of triangle out of it. Okay, you don't necessarily know anything about that triangle, what type of triangle it is, or anything like that, but you know that it's a triangle. Okay, now a little bit of a demonstration. Okay, let's imagine we have this. We have 10 on the bottom, and we have 8, and we have 6. Okay, so 8 and 6 are both shorter than 10 individually, but when I put them together, 8 plus 6 is greater than 10. So this does make a triangle. Okay, now you're thinking, oh, well, that seems like it would happen every time. Well, let's look at this next one. Okay, we have 10 again, but this time the legs, or A and B, are 2 and 3. Well, as you can see, it's kind of like short arms. They just can't reach each other. Okay, no matter how you turn them, these two sides are never going to touch because 10 is too big. Okay, and if I use the theorem, I see that 2 plus 3 is not greater than 10 because 5 is not greater than 10. Okay, so if you've got 3 lengths, 10, 3, and 2, then it is impossible to make a triangle. That is not a triangle. No matter what you do with those 3 sides, you can't make a triangle out of it. Okay, so this is our theorem. And basically, what it says is that if the short sides, the 2 short sides, are too short, then they can't make a triangle. Okay, A and B together have to be longer than C. Otherwise, they're not going to be able to reach each other because they have to start on the opposite sides of C. So they've got to be long enough to reach each other, which means longer than C. And one thing that I usually kind of think about to remind me of this theorem is like a T-Rex. He's got little short arms. He can't reach things. So that sometimes helps me remember what this theorem is talking about and why it works. Alright, so now let's see if you can determine if these three lengths can make a triangle. Alright, so the first one, you have three lengths, 6, 6, and 10. You need to determine if that can make a triangle. Okay, on number 2, you have 1, 3, and 5. Can that make a triangle? With 3, 4, 5, and 9, and with 4, 10, 15, and 20. Alright, so for number 1, all I'm doing is using my triangle inequality theorem. Okay, and it says the two short sides add together have to be greater than the long side. Well, 6 plus 6 is greater than 10. So yes, number 1 is a triangle. Okay, do I know what kind of triangle it is? No, but I know it's a triangle. Alright, number 2. I see that 1 plus 3 is not greater than 5. So no, number 2 does not make a triangle. There's no way to make a triangle that has lengths 1, 3, and 5. It's impossible. Okay, for number 3, I see that 4 plus 5 is not greater than 9. Okay, so again, this cannot make a triangle. Now some of you are saying, hold on, they would be able to reach because they're just as long. Okay, well, think about this. You've got this line right here. Let's say that it's 9 long. Okay, 9 feet long. Alright, well, if you've got, let's say, the 5 going from one end, and it goes straight back over the top, and then the 4 coming from the other side, and it would have to go straight back over the top. That's the only way they would reach, right? Because if they angle up at all, then they wouldn't be long enough. They would have to be right on top of the line because they're the exact same length. So if that happens, then you don't have a triangle. You have a straight line. So that's not a triangle. So this cannot make a triangle. Okay, that's why the inequality theorem is just greater than, not greater than or equal to, because it has to be bigger than C. Can't be equal to. Alright, and for number 4, I've got 10 plus 15 is greater than 20. So yes, number 4 is a triangle. Alright, now we're going to do a little exploring. Now, I really had intended for most of you to get to see this and kind of mess with the tiles a little bit, but this is what I have to do. So, we've got 2 right triangles here. Okay? I drew 2 of them just so that I could take this side and put it flat. But as you can tell, these are the same triangle. I just kind of turned it. Okay, this side's 3, that side's 4. This side's 3, that side's 4. Okay, and if you look down here, you can notice that this side is actually 5. Alright, and these are right triangles. So I need to put my right angles in there. Alright, so now there's something special that this guy named Pythagoras a long time ago noticed about right triangles. And he noticed it was true about all right triangles and only right triangles. Well, he noticed that if he drew a square, okay, on the side of the triangle that was the same as the length of that side, okay, so this is, since this length was a 3, this is a 3 by 3 square. And he did that on the other side. So since this was a 4, this was a 4 by 4 square. Okay, now since this one's not straight on some squares, I'm going to use this 5. Okay, and again, I have, since this is a length of 5, you have 5 by 5 square. Okay, now you can picture this just on this one, sticking out this way. Okay, and he noticed the relationship between these squares. Okay, take a second to count how many squares are in each of them. Okay, a 3 by 3 would have 9 squares in it. A 4 by 4 would have 16. And a 5 by 5 would have 25. And when he was looking at these numbers, 9, 16, and 25, he noticed something. He noticed that if he added 9 plus 16, it equaled 25. Right? But he didn't stop there. He tested it on right triangle after right triangle and noticed it was always there. That this pattern always showed up on a right triangle. Okay, so let's look at another triangle. Okay, this one is 6 by 8 by 10. And yes, it's a right triangle as well. Well, let's see if that works again. Okay, if I made a square here, it would be 6 by 6, or 6 squared. If I made a square here, it would be 8 by 8, or 8 squared. And if I made a square on this side, since it's a length of 10, it would be 10 by 10, which would be 10 squared. Well, is this a true statement? 6 squared is 36, 8 squared is 64, and 10 squared is 100. And 36 plus 64 is 100, and 100 definitely does equal 100. So you can see that this pattern shows up again, okay, in right triangles. Okay, now remember, we used A, B, and C to name the sides of a triangle. Well, which side is the longest? This side. That's why we called it C. Okay, on a right triangle, this is called the hypotenuse. Okay, the side across from the right angle is the hypotenuse. Okay, so if you look across from the right angle, that's always C, because that's your hypotenuse. Okay, now, so let's look at how we could come up with a formula to go from this to A, B, and C. Well, since we did 6 squared, and that was like my A, that's A squared. And then I added the other side squared, so I add B squared. And then that had to equal the hypotenuse squared, which is C, so C squared. Okay, this is your formula. This is your theorem. This is the Pythagorean Theorem. Okay, this is something that you should know. Okay, that you will know. And you will use. Okay, it's a very simple formula to remember. A squared plus B squared equals C squared. Okay? So you need to commit this to memory, and you need to know how to use it. Right? And this relationship, this formula, is true for all right triangles. Okay? If it's a right triangle, then this will be true. You'll be able to square this, add them together, and it will equal that squared. All right triangles. And on the other side, it doesn't work for any other kind of triangle. So if this formula doesn't work for something, that means it's not a right triangle. If it does work for something, that means it is a right triangle. Alright, so now let's see if you can identify whether or not a triangle is a right triangle. Alright, here's two triangles with the lengths. Alright, and you need to figure out whether they are right triangles or not. Alright, so looking at the first one. Okay, again, if it's a right triangle, then my Pythagorean theorem will work. Okay, well, the Pythagorean theorem says a squared, which is 15, plus b squared, which is 20, equals c squared, which is 25. Okay, well, 15 squared is 225, 20 squared is 400. Those are both from our quiz. And 25 squared is 625. You could always use a calculator for that. Okay, well, 225 plus 400 is 625. So yes, this is a right triangle. So I went ahead and put the right angle sign. Okay. Now, first, how did I know that the 25 was my C? Because if I didn't know where the right angle was, how did I know that was the hypotenuse? Well, isn't C always the longest? And which number here is the biggest? So it had to be the C. If there was going to be a hypotenuse, it had to be 25. Okay, and then when I find out that it is, I know the right angle is straight across from the hypotenuse. Alright, now let's look at the next triangle. Okay, we've got 10, 15, and 20. Okay, so a squared plus b squared equals c squared. Okay, it doesn't really matter, again, which one I call a or b. I could have called 15a and 10b because I'm adding, right? So 15 squared plus 10 squared is the same as 10 squared plus 15 squared. Doesn't matter. What does matter is which one you call c. The long one has to be c. Alright, so now let's work this out. 10 squared is 100, 15 squared is 225, and 20 squared is 400. Well, 100 plus 225 is 325, and that does not equal 400. So, no, this triangle is not a right triangle. Okay, so the first one was, the second one was not. See, Pythagorean theorem was true for this one. It was not true for this one. And that's how you can tell if a triangle is a right triangle or not. Now, here's the most common use for the Pythagorean theorem, and that's to find the missing length in a right triangle. Okay, and how do we find the missing length? Well, we have to use the Pythagorean theorem. So we have to use a squared plus b squared equals c squared. Okay, so 5 is my a. Okay, 7 is my B, and I don't know what C is, so I'm going to leave it as a C. Some people like to change it into an X. Okay? If I don't have a letter to give it, I just let it be a C. Why worry about more letters? Okay? So now I can solve this. This is solving an equation just like we did last section. Okay? So we have 5 squared is 25. 7 squared is 49. The other side still says C squared. Alright, now 25 plus 49 is 74. So 74 equals C squared. But I don't need to know what C squared is. I need to know what C is. Okay, so to get rid of a squared, what do I have to use? Yeah, that's right, I have to use a square root. So I have to take the square root of both sides. So the square root of C squared is C, and the square root of 74 is the square root of 74. I need exact answers, so I'm going to leave it as the square root of 74, and that's perfectly fine. Okay, so I can erase that and put my square root of 74. Now that is a right triangle. Okay? Notice, it's perfectly okay to have a square root as your answer. And we're leaving it just like that. Okay, but all I did was plug in the numbers I had and then solve for my missing value by using the Pythagorean Theorem. Okay? Now, the missing value could have been A or B. It doesn't matter as long as I plug it in the right spot. Okay, so I could have done the same thing and been missing A and had B and C and try to figure out what A was. Either way, you just plug in what you know, you leave what you don't out, and then solve for it. And you can find your missing links. Alright, so here's two triangles. For you to try to find a missing link for. Now, notice that these already say that they're right triangles. Okay? They have to. Because if these aren't right triangles, there is no way to find what this X is. Okay, or what this Y is. Okay, we don't know the relationship for other kinds of triangles. Okay, all we know the relationship for is right triangles. Okay, now we know the triangle inequality, which will tell me if it is a triangle. Okay, but I can't find a missing side with the triangle inequality. Okay, because it doesn't have an equal sign, it has an inequality sign, a greater than sign. So that doesn't really help me if I'm trying to find a missing length. So I have to use Pythagorean Theorem. In order to do that, it has to be a right triangle. Okay, luckily it is. So now all I have to know is the pieces that I'm missing. Alright. Oh, I guess I'll give you a second to work that out. If you need to pause it, you can. And then we can get started. Alright, so the X, which one is that? Well, it's across from the right angle, so it must be my C. Okay, that's the hard part sometimes is you don't know what size this is, so you can't just look at the numbers and say, oh, it's the biggest one, because I don't know what X is yet. Okay, so you have to know that the C is across from the right angle. Okay, so that's C, so then I'll call 4A and 5B. Again, I could have switched those, doesn't really matter. The only one that matters is which one you call C. So now I can plug it in. I got A squared plus B squared equals C squared. So that's 4 squared plus 5 squared equals X squared. This time they gave me a variable, so I'm going to use it. Alright, so 16 plus 25 equals X squared. Well, 16 plus 25 is 41. And to get rid of the squared, I have to square root both sides. So I get that X equals the square root of 41. And that's the length of this missing side. Alright, and for the next triangle, again I need to identify my sides first. The y, this time, is my A, or B, either way. But it's not my C, because C is across from the right angle. That makes the 10 my C this time. Okay, so that makes 5B and 10C. Now again, doesn't really matter which one you call A or B. Okay, I find it easier just to go ahead and call the variable A every time if it's going to be either A or B. But it doesn't matter which one you want to call it. Okay, so again, C is always the hypotenuse. That's one of the most common mistakes, is people just like to put the variable as C no matter where it is. Okay, if it's the hypotenuse, then yes, that's what you should make it. You should make it the C. But if it's not, then whatever the hypotenuse is has to be the C. Okay, so again, I'm using Pythagorean Theorem. A squared plus B squared equals C squared. Okay, so this time I have y squared plus 5 squared equals 10 squared. So that makes y squared plus 25 equals 100. Okay, this time it's a little different because my variable's not on the side by itself yet. So I can't just add the other side. I've got to move this 25 across. So I've got to subtract 25. And that gives me y squared equals 75. Now I have the square by itself, so I can square root both sides, and I get that y equals the square root of 75. And that's the length of this side. Okay? Now, if you note, the square root of 75 is less than 10. Okay? And it should be, because the hypotenuse is the biggest number. So the number I got shouldn't be bigger than 10. Okay, and it's not, so that's a good thing. Alright, now one last problem. And it's a word problem. Okay, about firemen. Okay, so some firefighters are at a burning building. And they're trying to get to a window. But there's fire all around that window. So they need to get exactly to the window. Okay, they can't miss it a little bit. Okay, but they also have another problem, is that they can't get the ladder closer than 40 feet away from the building because the flames are too big. Okay, so the ladder's got to be 40 feet away from the building, and the window is on the 3rd story. Okay, which means it's 30 feet off the ground. So they've got to figure out how long of a ladder do they need to take them straight to that window. Okay, so I'm going to give you a little bit of time and see if you can figure that out. How long does their ladder need to be? Okay, so the first hint I'll give you on any word problems like this is draw a diagram. Okay, even if you think you know what's happening, sometimes you don't notice things until you see it visually. Okay, so I'm going to draw it. Okay, there's my building. And we said it was 30 feet high, or at least the window I need is 30 feet high. Alright. And then there's obviously the ground, and there's 40 feet of ground in between where their ladder is going to be and the building, right? All right, and then there's a ladder. So I've got this ladder. Okay, so finish out the building. All right, now, so here's my building. Here's my ground. And here's my ladder. Okay, now notice, this is a right angle. Because usually in construction, they make sure that the building is actually going straight up. Okay, and this isn't the Leaning Tower of Pisa. Okay, so it's a right angle from the ground to the building. Now, something you may notice now that you may not have noticed when you were just reading it is the shape that you can see here. What is that? Yep, it's a right triangle, which you probably should have guessed since that's what we've just been working on. Right? So, you're going to have to use something to do with a right angle to be able to solve this problem. And since I'm trying to find how long the ladder is, well, isn't that across from the right angle? So isn't that my hypotenuse? So that makes the ladder C. Well, now I have A, B, and C. So I can use my Pythagorean theorem. And I get A squared plus B squared equals C squared. So that's 30 squared plus 40 squared equals C squared. Okay, so that's 900 plus 1600 equals C squared. So that's 2500 equals C squared. Well, now to get rid of the squared, I square root both sides. And I get that C equals 50. Now, but that's not my answer. Okay, because this question didn't ask me anything about C. It didn't say how big is C. It asked me how long their ladder needed to be. So, my final answer is that the ladder needs to be 50 feet long. Okay, and that's my answer. Now, notice, this problem wasn't any different from the other two problems that you just did. Okay, the only difference is you couldn't see the triangle in all the words. You had to draw a picture. And once you drew the picture, then you can see the triangle and you can work it out just like you did the other ones. Okay, so the two theorems that you should know now are first, the triangle inequality theorem. Okay, and that's that A plus B, here let's go back and look at it, that's that A plus B has to be greater than C. Okay, the two short sides have to be longer than the long side. They can't be shorter or you're kind of T-Rex arming it. Okay, so A plus B has to be greater than C to make any kind of triangle. Okay, to make every kind of triangle. Okay, and then we also have the Pythagorean theorem, which is A squared plus B squared equals C squared. Okay, and that only works for right triangles, and it works for all right triangles. Okay, so you should be able to use both of those to tell if a figure is a triangle and to be able to tell if a figure is a right triangle. And you should be able to use the Pythagorean theorem to find the lengths of missing sides, either A, B, or C.